Hello. In this video, I would like to discuss the logarithmic function as it relates to exponential functions. The logarithm function is the inverse of an exponential function. It is used as a technique to solve exponential equations where the variable is the power of an exponential. As a rule, base values b that are positive and not equal to 1 when written as an exponential equation, b to the x power equals y, can be rewritten as logarithm base b of y equals x. You will find that solving exponential equations is made easier by rewriting exponentials as logarithms and vice versa. Here are a few examples of rewriting exponential equations as logarithms. You should recognize that 5 squared is equal to 25. This exponential equation can also be written as a logarithm. Logarithm base 5 of 25 is 2. In the next example, we see that 4 to the third power is equal to 64. When written as a logarithm, we would have logarithm base 4 of 64 equals 3. The exponential equation 1/2 raised to the power of negative 2 equals 4 would be rewritten as the logarithm base 1/2 of 4 equals negative 2. What do you think this last example would look like when rewritten as a logarithm? It would be logarithm base 10 of 0.01 is equal to negative 2. Please note that logarithms with a base of 10 will often be written without the base number specified, but rather implied. In these next examples, we are provided with a logarithmic equation and are being asked to rewrite them as an exponential. In the first example, we have a logarithm base 2 of 16 equals 4, and it should be rewritten as 2 to the fourth power equals 16. In example 6, we have a logarithm written without a base, therefore it's implied that the base value is 10. So, written as an exponential, we have 10 to the third power is equal to 1,000. Please try the next two examples on your own. Pause the video now and resume playback in a moment to check your work. "49 to the 1/2 power equals 7, and 2 to the power of negative 2 equals 1/4. For the final examples, we are being asked to evaluate logarithms. When evaluating, I find that it's easiest to do so by writing an equal sign, then the letter x for our unknown. In each of these cases, you might try to use a calculator to evaluate the logarithms, but oftentimes calculators cannot handle logarithms without a base of 10. If we rewrite logarithms as exponentials, we might be able to solve the equation for x on our own. In example 10, we would like to rewrite the logarithm as the exponential 2 to the x power equals 8. And you should also recognize that 8 is the same as 2 to the third power. Therefore, x is equal to 3. And we would say that this logarithm evaluates to 3. In example 11, we might think that 9 to the power of x equals 9, and recognize that x must be 1. Therefore, this logarithm evaluates to 1. Please try the last two examples on your own. Pause the video now and resume playback in a moment to check your work. The logarithm in number 12 evaluates to 3, and the logarithm in number 13 evaluates to -5. You may have noticed that 3 to the 5th power is 243, but it takes a negative exponent to create the result that is a fraction. I hope that this practice helps you with your understanding of logarithms and allows you to better perform with more complicated examples that you will see in the future. Good luck.